global preferences area in Wireshark will affect a number of different locations on the window and a number of different behavior patterns. For example, you could set up Wireshark so that in the title bar it has your name or the company name where you're taking the trace files. You can set it up so that the 3-panel display is different. You could set it so that when you say File Open, you go to a specific directory each time, or you go to the last directory you selected. In many cases, you can also override these settings when you go into the Capture Options area and you define a new display option setting or a new name resolution setting. To get to the Global Preferences area, we can select Edit Preferences, press Shift-Control-P, or on the icon bar, you could select if you have Wireshark maximized, you can select the picture of, or the icon of the screwdriver and the wrench crossing. In this module, we're going to focus on defining the user interface and setting the user interface preferences. And I do automatically go in all the time and make changes to my user interface settings. I'll show you this window. Keep in mind that when you change any of the settings, you need to click the Apply button in the bottom right-hand corner to make those take effect immediately. And then also, I'm going to have to move this window around a bit so you can see the effect of changing some of these settings. The first two settings have to do with whether you're selecting or browsing in the packet list selection or the protocol tree area. So I'll show you what this does. The packet list selection is this area up here. Right now, the way it's set, if I select this DNS packet, then in that middle window it's going to show me that DNS packet. If I select this handshake packet, it's showing me this. If I go to the preferences area and change it to browses, remember that you've got to select apply in order to make those settings take effect. Now I'll go back now that I've set that, and you'll see the middle window is empty. And now as I scroll through, I'm not seeing the detail of each of those packets. They might flash up for a moment, but they're gone for me. I'm actually browsing through, not selecting them. I don't really like to browse. I prefer to select wherever possible. We have the same option in looking at a protocol tree listing. Now the next three options have to do with the window position, the Wireshark window position itself. We can say that we always want the window to open up in the same location. We want to keep that window size all the time. And then whether we want to open up in a maximized state. We also have a console window, and the console window provides us with some debugging information with regard to Wireshark. Now I have mine set up to automatic, that if something comes up, the console window will pop up and I'll be able to see what the message is from Wireshark. And it is just a console prompt with messages that Wireshark is piping up. The File Open dialog behavior allows me to define whether I say File Open and it always goes to one directory, or it always goes to the last directory I was using. So for example, maybe I have created a traces directory, and I always want to make sure I start in the traces directory. I can select that, put in the directory structure. There is no browse button at this time in this version that allows you to select that directory, but maybe in a future version we'll have that. The File Open Preview Timeout has to do with how long you will be looking at preview data in the File Open dialog box. And this one right here is one that I do change. I really like this. This is the Open Recent Maximum List Entries. And when I go out to capture trace files, I'm often capturing hundreds of trace files, and I go back and review the same trace file numerous times. So when I say File Open Recent, right now I'm set to 10, so I'll see the last 10 trace files I was looking at. But if I'm out at a customer site and I'm going through hundreds of trace files over and over again, I don't want to only see 10. I want to bump that up, and usually I'll set that to 25, maybe even 30. Remember that none of these settings will take effect until I click the Apply button. So now I'll click Apply, and it will start gathering that list up to 25. Wrap to the end or beginning of a file during find has to do with, if I'm looking through this trace file and I select that I want to find a packet, maybe I'm looking for a specific text string like Nessus in the trace file. If it gets to the bottom of the trace file, we'll automatically wrap to the beginning. I do like that setting, and so I have it set on. And the last piece is the settings dialog show a save button. Now right here you'll see that we don't have a save button. When we click apply, it's implied that we want to also save those settings and use those again. So if we want to, we can bring back that Save button. Now once I've selected what I want, I'm going to click Apply, but I want to look under some of the other options in the user interface area and show you what we can do. In the layout area, this has to do with, first and foremost, the panels that we see in the background. The default setting is a 3-panel display. That top window is what I call the summary window. It lists all the packets that are seen with some basic information on the packets. That middle window, if you select one of those packets, in the middle window you'll see the detailed decode window, or the packet information. In that bottom window, we can select something in the middle window. In the bottom window we see our hex decode, or the byte detail of that window. Now most analyzers have that 3-panel display set up so that panel number 1, the top panel, will give us the packet list or the summary information. Panel number 2, the second panel in there, will show us the packet details or the detailed decode information, and then panel number 3 will show us the packet bytes. But if you like a different layout, you can certainly select a different layout. So I've just selected the second layout. I'll apply it. Now in the background, when I go look at Wireshark, I'll have my new window setting. I'll have to do some resizing here. So I've got my summary window on top, I've got my detailed decode on the left-hand side, and I've got my hex window on the right-hand side. If you never use the hex window, you can also get rid of that by changing panel number 3 and saying that you do not have anything showing up in panel number 3. If you totally mess up your panels and you don't like what you did, you can always click on the default panes button and that will take you back to the default setting. Now the vertical scroll bar placement, this has to do with, in the background setting, where those scroll bars are. Since I selected default panes, I'm going to select Apply so that it brings me back to the original view. But the scroll bar, this is just where the location of the scroll bar is. Now I can change it from left to right. In addition, do I want alternating row colors in lists and trees? And this might make it easier to see the packets and differentiate the packets and things like that. But I've already got colorization on and I'm using colorization to see that. The hex display highlight style, we have 2 options. We can look at inverse, we can look at bold. Now I've got it set for inverse and I really think that that is the clearest way to look at this. So I'll show you what that means. It means that if I'm looking at a TCP packet and I'm interested in the flags field, down below in the hex portion it's highlighting the flags field setting. If I put it in bold, it really doesn't show up well enough, so I keep it in an inverse highlight selection style. The toolbar style area has to do with the toolbars up here. I've got mine set for icons only. We could also say that we want icons and text or just text only. And then the filter toolbar placement has to do with my display filter, where my display filter sits. I have 2 choices. I can either have it sit right up here underneath my toolbar, or I could bring it down here so that it's on the status line. So you can see the insert into status bar. That's the status bar down below where you have your packet count, your displayed packet count, marked packets, and if any dropped packets are listed in there, you'll see the drops listing. Now, this one I do change all the time. This is the custom window title. It prepends it to the existing title of a file. So if I'm working at a customer site, maybe it's customer ABC, and I'm at location A, I can place that information into the title bar, so when I do screen captures, it'll always show up in my screen captures. So I know when I'm looking at any one of the screen captures exactly what customer I was at and which location I was at where I gathered those packets. I like that setting a lot. In addition, you can put your name in there, and that will show up in front of every one of your trace files all the time when you do your screen captures, which is really nice. Now I'm going to go over to the columns area, and the columns area can be a little bit tricky. And the reason is this. We're looking at the columns in this top window, and we may want to add some columns. Now, the column I add most often is the packet length column. Sometimes I like to scroll through traces and see how long the packets are, so I can differentiate easily amongst ACK packets or packets that might contain data. In order to add a column, I'm going to click the New button, and down here I've got to give it a column name. So I'm going to call this column length, and it's going to be in bytes, I know that. And then I must select the format, and there are a number of predefined column formats. Now there's a little bug in here so that when I click this down arrow, I'm going to have all this blank space sitting up above. And I'm going to scroll down to the section where it says length, and unfortunately this is going to scroll right off of your screen. There we go. So I just selected the one that said packet length in bytes. And there's a note here that unlike all other preferences, you have to save and restart Wireshark to let the column changes take effect. Well, I don't have an explicit save button there, so I'll click the apply button, and I know that that's the same thing as save. Now I'll click OK. I've got to close the preferences window down because I've got to restart Wireshark in order to see the length column show up here on top. So I'm going to take a moment here and restart Wireshark. Now I went ahead and restarted Wireshark. Now I'm going to open an existing trace file. And my new column should be available to me on the right-hand side here. And there it is. There's my length column. Now I'm trying to run this so that you can see this better. So I'm running it in 800 by 600 mode. So I'm a little low on space on the right-hand side. But not only can we see the length column there, but we can also sort on that length column. So we can get all the big packets showing up on top. And we can see, oh, there we go, good. 15, 14 byte packet sizes for file transfer. And that's what we want to see on something like an Ethernet network. The last 4 bytes are going to be put on by the network interface card. And that's why you don't see the 15, 18 byte value that you might expect. So we can see that we have our new length column in there. On the left-hand side, I'm going to go back to sort according to the number column field again. And let's go back into the preferences area. Now, we worked with the columns area. As I mentioned before, down below you'll see that there's a note there that you're going to have to save and restart. If you wanted to change the layout of the column so that maybe the length column was, right after the time column setting or something like that, you can move it up or down. We can apply that. Remember though, that's one of those settings that you're going to have to restart Wireshark after changing. Now the font area has to do with clarity, really. So if I'm in a class, or maybe I'm projecting the Wireshark screen, or someone's looking over my shoulder, and this font size is too small, I can change the font size to a larger size. So right now I'm set for Lucinda Console. Maybe I want to go from a 10-point font to a 12-point font. And it'll show me down below what it looks like. This is one that I don't have to restart on. I can just click on Apply, and I can go through and see my new settings. We can see that it's a lot bigger. I have to go back to a 10-point because with this screen resolution, that's just going to be way too big. I won't be able to see very many fields. Now when you change your font setting, you'll notice that you might have some extra space there, some extra white space there. And that's kind of a pain to see that. But remember, you can always resize your columns. You can do that either manually, or you can go up under View and say that you want to resize all columns. And they'll lay themselves out nicely for you again. Now, colors doesn't have to do with the colorization of the packets. Like you see, my ARP packets are in light blue, and my DHCP packets are in dark blue. It doesn't have to do with that. It has to do with the color of marked packets. So right now, if I click on a packet and I right mouse click and say that I want to mark it, if I move away from it, you'll see that it's got a black background and a white foreground. This also has to do with the TCP stream client text and the server text. So I'll show you what that looks like. Let me move this out of the way just a little bit. I know that I have an HTTP session in here, and there it is. So if I right mouse click on that session, I can say that I want to follow the TCP stream, and another window appears. Now, according to the settings I have in my colorization, the client communications show up in red, and the server communications show up in blue. Although it's hard to tell, the red has sort of a light highlight background, and the blue also has that highlight background. And if I wanted these to show up maybe a little bolder, I could change the look of that by altering the foreground or the background on any one of those. So we just select the drop down, and we could say that TCP stream client background. I mean, right now it's this very pale color down here. Maybe I want it to be bolder. Maybe I want to change the opacity of it or something like that. So all of these things under user interface, all these areas under user interface really affect the way Wireshark looks and the way we open files, whether they're recent files or we're opening from a specific directory. In the next module, we'll take a look at the capture settings area. Probably one of the most important preferences that you will set has to do with how you capture traffic off of the wire. So we're going to select Edit Preferences, and in the Preferences window I'm going to select Capture. Now up on top, the first thing you have is the default interface. And this can be really irritating if this is set wrong and you're always capturing off of one specific interface from your system. If you click the drop-down list, you'll be able to see what interfaces are available to you. If you don't see any interfaces in there, that means Wireshark doesn't see any interfaces. So you may have a problem with WinPCAP. One thing you can do if you have that problem is you can restart Wireshark, but if it's a WinPCAP problem, you're really going to want to reboot your system. So I have mine set for my NVIDIA card on my system. We also can go in and edit that list a little bit and make some changes to it. So I selected the Edit button. And now here we can see I have a generic dial-up adapter listed here. And if I don't ever want that to show up on my list, I can say that I want that to be hidden. Or I could put in a comment in here. I don't use this adapter. Something like that. In addition, if I have notes about an adapter, just go ahead and put it in. Now, because I'm using Wireshark on a Windows system, I have problems capturing wireless traffic. I would not use this wireless card to capture the wireless traffic. Instead, I would add an AirPCAP adapter to my system. You can get an AirPCAP adapter online from www.casetech.com. Now I'm going to select my default adapter again as my NVIDIA adapter and say OK. You can see my comment showed up on the right hand side. There you can see that little comment that I don't use this adapter. None of my adapters are hidden at this time. So we can see under Hide it says No. Now the default settings are shown here to you. Capture packets in promiscuous mode. Promiscuous mode means that we will capture all packets even if they are not addressed to or from our network interface card, or they're not a packet that our network interface card would normally process, such as a multicast packet or a broadcast packet. If we take off this setting, then we're only going to be able to see broadcasts, multicasts, and traffic to or from our network interface card. And that really defeats the purpose of doing packet analysis and listening in on traffic. Now it may feel like this setting is already turned off so that we're not looking at packets in promiscuous mode when we connect into a switch. And section 1 in this course dealt with how to tap into a switched network, what your options are for packet capture in a switched network. Update list of packets in real time I really like because I like to see the packets as they arrive in the background here. So I usually set that on my system and I'll turn it on here. Now even though I click Apply on this window right now, that's one of the settings that will require you to restart Wireshark. Automatic scrolling and live capture. A lot of people turn that on. What that means is as the packets are arriving and you're viewing the list of packets in real time, you are automatically scrolled to the last packet that arrived. Now realistically, on a busy network, you're never going to be able to keep up with the packets as they arrive and you're scrolling through them. So I typically have that turned off. The only time I might have that turned on is if I have a very, very specific capture filter or a display filter set up in the background so that I'm only seeing a few packets as they arrive. But other than that, I keep that setting off. Hide the capture info dialog. Let me show you what the capture info dialog box is. I'll go ahead and close this window out. And I'm going to start capturing some traffic on the cabling system. I want to make sure I don't have any capture filter. No capture filter. So I'll say OK. Remember that even though I said I wanted to see the packets in real time as they arrive, I really need to restart Wireshark in order to make that happen. This is the capture info dialog box, and for a lot of people that can be very irritating, and I do typically like to turn it off. It's nice that we can see how many packets we've caught and how many are different protocols, but I can see the packet capture count down on the status bar already. So on my system, I'll go ahead into my preferences area, and I'm going to set that so that that window is not showing anymore as I'm capturing. In that case, to stop a capture, I would just use the stop capture button on the icon toolbar. There we go. Now, as I mentioned before, this is one of those areas that we really want to restart Wireshark in order to see these new settings. So I'll click Apply, and then I'll click OK. And now, just for a moment, I'm going to pause as I go out and restart Wireshark. So now I've restarted Wireshark, and those settings should take effect. So when I begin to capture, there are my interfaces that I have right there. When I begin to capture off of that interface that I've defined as my default, I should be able to see the packets arrive live, and I don't have that irritating capture info dialog box showing up. Now if I want to stop capturing, I would click on this button to stop running the live capture instead of doing that through the info dialog box. Now we should be able to see that I'm capturing packets not just to my workstation but to and from other systems. But I'm hanging off of a switch, and again, section number 1 in this course deals with capturing packets off of a switch. Remember that although you set these preferences as global preferences, you can override them when you capture packets. If you click on the second button, that will take you right to the capture options window. And here on the right hand side, I can say, you know what, when I capture now, I don't want to update the list of packets in real time, and I do want to see the capture info dialog box. Now when I start, I'm going to continue without saving. We'll see that I'm back to my capture info dialog box showing up, and I'm not able to see the packets as they arrive. This ability to override the global preferences area is available for not only your preferences with regard to capture, but also your preferences with regard to name resolution, which is the next module that we'll go on to. Before I do, I'll just mention in the printing area here, we have the ability of defining our printing preferences, what format when we export our data from Wireshark. We can say we want to print to a printer, we want to print to a file, and the file, we can select what the file name should be, as well as the format that we're going to export to. In this module, we'll look at the preferences for name resolution. So I'll select Edit Preferences, get to the Global Preferences window. Now we're focusing specifically on name resolution, and this can affect performance, and it can also affect how quickly you can troubleshoot things by knowing the names of the systems communicating on the network, not just getting IP addresses. In this window, the first option we see is the option to enable or disable MAC name resolution. And MAC name resolution will resolve the first 3 bytes of the hardware address to a vendor ID. So let's take a look at that and how you might change the way that behaves. Right now I'm going to set up Wireshark to capture. And remember, as we set those global preferences, we can override these things when we do an individual capture. So I have Enable MAC Name Resolution set on, and I'll go ahead and start capturing traffic from this interface. Now, in the background, we can see a number of ARP packets going on. And when we look at the detail window here, and we look at the Ethernet information, if Wireshark recognizes the first 3 bytes of the MAC address and can associate it with a vendor, it will place the vendor's name there instead of just the first 3-byte value. So let's scroll through and find some packets where it has that setting. I'll tell you, the network I'm on has a tremendous amount of ARP traffic, and I don't like it, so I'm going to do a quick little filter here to get rid of the ARP traffic so we can see some other traffic on the cabling system. There's a DHCP packet on the cabling system. Now here's one where we have enabled network or MAC name resolution. We can see that it's resolved the first 3 bytes, the 001731, to be an Asus Tech C whatever network interface card. Now it's getting that information from a specific file. Let me take you out so you can see that file. Wireshark's manufacturer name listing can be found in the Program Files Wireshark directory, and the name of the file is MANUF, short for manufacturer. Here's the file. If I want to, I could edit this file by right mouse clicking, saying I want to open the file, edit it in perhaps Notepad, but I'll tell you, for visibility's sake, looking at it in WordPad is a lot better. But we have to be careful of WordPad adding any special characters to the file and corrupting the file. So here you can see that list. There they are. And maybe I don't want this card showing up Maybe I'll pick one down here. Maybe I'm looking at a card and I don't want it showing up that this is a Rapid 5 NETW Networks card. I don't want that to show up. I want some other name. I could go in and I could edit it. Most likely I would edit this not in WordPad but in Notepad and put in a new name. Or maybe I have some additional manufacturers I want to add to this list. I can go ahead and do that. And that will affect Wireshark. Now we're going to skip the network name resolution for a moment. I'm going to come back to it because there's more than one area in here that deals with network name resolution. We have a checkbox here for enabling network name resolution, and then down below we have the ability to define that we want to do concurrent DNS name resolution queries in the background and how many concurrent queries we want to allow it to do. But I'll look at this one first, which is enable transport name resolution, and I have that turned on. Now what this will allow Wireshark to do is, instead of putting in the port numbers here, so we see all this DHCP traffic, and instead of putting in the port numbers of the DHCP traffic, we will see it put in the name of the communication. So here we can see boot PS, that's DHCP in my case, the server side, is port number 67, and boot PC it's put in instead of just putting in the number 68 here. So this way when I web browse and things like that and I see HTTP traffic, it'll show up as HTTP traffic in the decode down below and up above in the protocol area as well. I'll show you what that looks like if we turn that on or off. So right here I'm going to go ahead and start capturing some traffic, and in my capture options area I have it set to enable transport name resolution, so I'll go ahead and start. I don't want to save that previous trace file. Now I'm going to toggle over, oh, never mind, I've got some HTTP traffic already in the background, and we can see right there it says HTTP instead of just saying port 1177 going to port number 80. If we turn that off, then port number 80 will be showing up in this area. If we don't want to turn that off with global preferences, we can start capturing, and we can define this specifically for this one capture session. So I'll turn that off, click Start, continue without saving. Now, if I get some HTTP traffic, you'll see that it will come up, and now we've got the 1166 going to 80. It doesn't have the letters HTTP in there. I'll stop capturing, and I'll tell you, I usually leave the Enable Transport Name Resolution on. So where does it get these names from? Let me show you the directory where the services file resides. The services file resides in the Windows System32 drivers etc directory, and there's the file. You need to be careful if you're going to edit this. You don't want to cause corruption to the file or anything like that. So I'll right mouse click and say that I want to open this file so we can view it. And I'm going to open it with WordPad, which will be all nice and neatly formatted for me. And as you scroll through here, you'll recognize a lot of these ports. There's my port 80 comes up as HTTP. There's POP3. So you should be able to recognize a number of these settings here. If you have an application that uses a specific port number, you may want to add it to this so that Wireshark recognizes that application and puts the name there instead of the port number. Now let's tackle the issue of network name resolution. I typically leave this off because as a protocol analyst, I want to be silent on the cabling system. I don't want to add to the traffic. I want to listen in on the traffic and do my troubleshooting, optimization, and security work in a passive manner. If you turn on Enable Network Name Resolution, then Wireshark will go through and do inverse DNS queries in order to try to resolve a name and associate that name with an IP address. And you might find that you add a lot of traffic onto the cabling system as you try to resolve every IP address that you see as you're capturing. I'll show you what that looks like if we turn it on. I've enabled Network Name Resolution. And down here I have said that I want to do concurrent DNS name resolution. That means that we can send out multiple DNS inverse queries at the same time, and this is how many I will allow to run simultaneously. I'll apply this setting and say OK, close down this window. Now remember, if you don't like that setting, you can always override it, because when you go into the capture options area, you can come in here and say, oh, I really don't want to do that. But we'll leave it on for this moment. I'm not going to save the previous trace file that I kept. Here we see some traffic, and now what we see is we see these names coming in. And all of the names that are showing up here have to do with names that I've collected using inverse queries. So here you can see my system is sending out all this DNS traffic. And if I start browsing around, my system will try to do inverse queries to find the names of any other system that I see communicating in this trace file. Now, I don't like turning that on because I don't like all that background traffic, but sometimes I like seeing the name of a host rather than the IP address. There is a little trick you can do, and you should be aware that this is not pulling from the hosts file that you have on your local system in order to do this. This is building a list dynamically in the background. So here's a little trick of something you can do if you wanted your system to always show up with a specific name. For example, I don't like this name that it resolved for my local system here. I want it to always show up that my system is called the HP Lab 01 system. I'm going to create a host file, and I'm going to place it in my user profile application data Wireshark directory. So now I'm in the documents and settings, my user profile directory, application data, and Wireshark. And in here, I'm going to create a new host file. So I'm going to right mouse click and say that I want to create a new file. It's going to be a text document, and I'm going to give it the name of hosts and save. Of course, when I rename it, Windows will complain about that, but that's okay. The host file should have no extension. Now I'll right mouse click and I'm going to open this. I'm going to open this with Notepad. There we go. Now I need to put in the IP address of my local system. And here I've run ipconfig so I can see what my IP address is for my local system. So I'm 67.180. Got to type it in right. .72.131, and I want it to show up as HP Lab 01. Now I'll go ahead and save that file. I can close it down. And I don't need my ipconfig window anymore. Now you should know that Wireshark will behave differently depending on whether you're applying that brand new host file to a live capture or to saved captures. Now I'm working on live capture, so I restarted Wireshark. Now when I select I want to capture the file, we'll see that network name resolution is on. I'll click Start. And now when I see the traffic in the background to or from my local system, it should come up and say, there it is, HP Lab 01. Now if your names don't make sense at all, always remember that you can go through and you can edit that host file or delete that host file or give it a different name so that it doesn't automatically place these names on there for you. But keep in mind also that you may want to go ahead and restart Wireshark after you play with the host file so it pulls up the latest information for you. And remember, that's not the normal host file that Windows looks at. This is a different host file. This is one that Wireshark specifically will look at when it does name resolution. But as a final note, I really try to work without the network name resolution turned on. I don't like setting all that traffic in the background. So typically I'll work with that piece completely turned off, and then I'll work with IP addresses and just live with it that way so that I don't send all those inverse DNS queries out on the cabling system. Another interesting place where we can change the global preferences in Wireshark is in the area of how it handles protocols on the cabling system. So if we go into the Wireshark preferences area and then we open up the protocols section, if you just scroll through, you will see the settings that are available for each of the various protocols. Now I'm going to start with one that you might work with, which is the TCP protocol settings. And I'll show you what some of these can do. First of all, show TCP summary in the protocol tree. If I bring this window down, I'm looking at the summary in the protocol tree. You can see it says transmission control protocol, the source, destination port number, the sequence, and the length number of the packet. If I wish, I can turn that off, apply that change. Now bring this window back down again and see that now it just says transmission control protocol. Now I really like having that full list of information, so I'm going to turn that on. Another option has to do with validating the TCP header checksum. So I'll go back to that window and I'll take a look at a checksum in this TCP header here. There we go. It says the checksum is correct. Now just a note here, sometimes you may find that there are problems where you look through the trace and all the TCP header checksums are incorrect. Don't panic. Most likely what's happening is that your system is doing TCP checksum offloading to the network interface card. So when Wireshark sees the checksum value, it hasn't been placed on there yet, so it marks it all as incorrect. If that's the case and you just get all of these checksum values showing up as incorrect, you can go into your preferences setting and you can turn off the TCP checksum validation. Here's an example of when you may want to turn off that setting. I've opened up a trace file where all through this trace file in the TCP headers I have these notations in red saying this checksum is incorrect. It should be this other number, and it says may be caused by checksum offloading. That means the sending system is offloading the checksum calculating process to the network interface card. So as packets go out, I don't have the checksum that matches that packet. And when packets come in, the checksum is done on the card on the way in also. So I'll see that as bidirectional. All of these, and it's really irritating to see that. So in this case, I might go in to my preferences area, and in TCP I'll turn that off, but I'll show you what it looks like when you turn it off. It doesn't mean that the checksum field is going to be just zeroed out for you. So I'm going to turn that off and apply it. Say OK. Now I still see that these packets are showing up in black, which means that there's some sort of a problem that the expert system is noticing, and the colorization system is set up for that. But now I see the checksum value, but there's a notation here that validation has been disabled. Allowing a subdissector to reassemble TCP streams may take extra memory on your system, so it might be something that you don't want to have on. Right now I don't have this setting on, and when I look through this HTTP communication, I see all the packets going back and forth. There they all are. But I don't see any notification that there's reassembled frames in there. If I turn this on and apply this change, now I'll move the window out of the way. Now as I scroll through, I start seeing these notes that this is a TCP segment that's part of a reassembled PDU. And if I look inside the TCP header of one of those packets and scroll to the end of the TCP header, we can see this is part of a reassembled group right there. There's the data. And I'll scroll down a little bit further. There's my data in here. Now, on one of these, as I click there, you'll see that there's a notation that says the reassembled PDU in frame 141. So it's telling me that the whole entire reassembled set is sitting in packet number 141. So I'll scroll down to packet number 141. There it is. And down here, this is the whole entire reassembled set. So all that data in there contains all of the reassembled packets, and it lists the TCP segments that have been reassembled. There's a total of 6,750 bytes. Packets number 132, 135, 136, 140, 141 is that whole entire set. And when I look at this one packet, I have all of them reassembled for me. Keep in mind, though, that this takes extra memory, so you may not want to turn that on unless you absolutely positively have to use that. Wireshark also has the ability of analyzing the TCP sequence number values. So in here, and there's a notation, if you just place your cursor above that, it tells you that this will make the TCP dissector, or the decode, analyze TCP sequence numbers to find and flag retransmissions, missing segments, and the round-trip time values. This is a nice thing to have on. So I've got that turned on, and as I look inside of my TCP communications here, scroll through these, you will see that here's a sequence and acknowledgement notation here. This is an acknowledgement to the segment in frame 136. And it also tells you up here that the sequence number 363, the acknowledgement number value is 4081. So it's using these two values when it puts this together. I go back up. Relative sequence numbers and window scaling. This is another one that I like to have on by default. So if I bring this window down, I'm going to go to the beginning of a TCP handshake process, and here we can see this is a handshake making an HTTP connection. The sequence number field is set at 0, but in real life it's not set at 0. If I go into the TCP packet and highlight the sequence number field, I can see in the detailed decode window it says it's set at 0, but down below I can see that this is actually the number. It's just much easier to work with numbers starting with 0 instead of these big high numbers. But I'll turn that off and show you what it looks like. And we'll go back to that same packet, which is packet number 148, after I turn it off. So I'll turn it off, apply that change, come back into packet number 148. I'm in the TCP header, and there's the sequence number value. 28054633349. That can just be really cumbersome. Now I'll tell you when I do turn that off. If I've got two Wireshark systems on either side of a router, and I'm capturing traffic simultaneously on either side of that router, I want to correlate one of those communications with the other communication just somewhere inside that data stream. In that case, I might turn off that relative sequence number and window scaling piece so that I can see exactly what the sequence number is on both sides, and I'm absolutely certain that I'm matching up the packets as it went through the router perfectly based on the sequence number value. Now you need to know that by turning off this option right here, you're not only affecting the relative sequence number process that Wireshark uses, but you're also affecting the window scaling process that Wireshark uses. And that's related to the TCP header options value of a window scale. I'll close this window down, and I've opened up a trace file in the background. And in this trace file, in one of the handshake packets, in the options area, we can see that there's a window scale value set. Now this affects the window size value that's being advertised by this device. So if it multiplies the window scale by 2, it would be 2 times this number. And Wireshark will show you the multiple value here instead of just calculating it out looking at this information. It'll just pop that number right up there. You'll learn more about the window size field in the TCP/IP network analysis course that's available as part of Wireshark University. Let's go back into the Edit Preferences area and look at some of the other protocols that you can configure in the Global Preferences area. So now I'm back in here, I'm going to look at IP. Now you have some areas in IP where you can affect the processing as well. Reassemble fragmented IP datagrams. The default is on, and I can open up a trace file and show you what this looks like now. So I'll close this window down, open up a trace file that I have that's called pingfrag. Now this is just simply a ping process being sent out on the cabling system, and the packets need to be fragmented. And we can see that Wireshark has put in a note. This is a fragmented IP protocol. And there's another packet of the fragment set. If we open up the IP header in these packets and scroll down, we'll see a notation that these are all reassembled in frame number 3. So I can go to frame number 3, and it tells me, just like TCP segment reassembly, it tells me the packets that are part of this segmented set. One other thing to note is that when you're in one of those packets that show this line saying that it's part of a reassembled set, and it's the same thing in TCP as it is in IP, I'm going to have to move this up just because I'm going to have a drop-down window that you need to be able to see when I click on it. So when you see one of these lines, you'll see they're underscored and you'll see that they're blue. That means they're a hyperlink. And you can right mouse click on that packet and select Go to Corresponding Packet. And that'll take you right to the packet where everything is reassembled. So it's a quick and easy way to get around. If I turn off fragmentation reassembly, I'll put all these back together again. And then I would have to go packet by packet to look and see what the set looks like. So I'll go down to IP, turn off the reassembly process, apply it, say OK. And now we'll see packet number 1 says it's a ping packet. Packet number 2 is a fragmented IP protocol packet. Packet number 3 is fragmented IP protocol. But each of those packets has just a piece of the fragment set, and they're not reassembled in any single one packet. Keep in mind that just like in the world of TCP communications, segmentation reassembly may take a fair amount of memory. If somebody sends you a 1 gig ping data stream, it's got to reassemble all of that with fragmentation reassembly. So you might want to think twice about turning that on. Now we'll go back over to the preferences area. take you back over to the IP area. And I'm really just focusing on some of the main ones that you might use when you're working with Wireshark. Validate IP checksums if possible. I typically turn that on. Show IP summary in the protocol tree. Of course, that means that in this area down below, this part of the window, do I want to see all this information along this line, or do I just want it to say Internet Protocol? Now, on some of the protocols, you can change the port that those protocols run on. So, for example, I'm looking at Quake, just standard Quake, and it's set up to be running on port 26,000. And Quake 2 is at 27.910, and Quake 3, 27.960, 950, and Quake World at 27.500. If I know that I have a group of people that are running Quake on port 27.501, I can change it in the global preferences area, or if I see the traffic, I can do protocol forcing, and I can state that all packets that use port 27.501 should be protocol forced to the Quake World protocol set and the protocol dissector. You'll see more information about protocol forcing in section number 10 of this course. So you can see there are a lot of places where you can affect the way Wireshark deals with the protocols. Keep this in mind, and as you grab traffic, perhaps you grabbed a whole bunch of LDAP traffic, maybe you want to look at that and see how changing some of these settings affects the decodes that you look at. Now I just briefly want to show you some of my favorite settings for global preferences for Wireshark. In the user interface area, I do like to have the Open Console window set for automatic. I like to set it up to remember the last directory I was in, because typically I'll go back to a client directory over and over and over again instead of in some standard directory. I always do change the Open Recent Max list entries, set it up to a higher value than just the standard 10. In the layout area, I do keep everything set as the default all the time. I'm used to working with so many protocol analyzers, and that's a standard look, and I'm used to that. In the custom window title, I do put my name in there so that when I do screenshots, I can have my name sitting right there inside of the screenshots. In the column area, the column that I most often add is the length column that allows me to sort through the packets and gather all the data packets together. In the capture area, I do like to have the list of packets updated in real time. I won't do that if I'm working on a flooded network, but all other times I do like to have that. I do also make sure that my default interface is set as the main card that I want to use. And if I do have a wireless card in there, I may put a note in there saying, don't forget your air PCAP adapter. I don't like the capture info dialog box, so I check that to turn that off. I never do automatic scrolling and live capture, really. I mean, very rarely, I should say. I shouldn't say never, but I mean, only if I've got a really serious capture filter or display filter set so that I only see a few packets anyway. Then maybe I'll do automatic scrolling and live capture. But other than that, I'm usually working on networks that are so busy I wouldn't be able to keep up looking at it that way anyway. In the name resolution area, I do not like having network name resolution turned on because I don't like adding those packets onto the cabling system. If anything, I might make myself a special hosts file and put it into that directory, as I mentioned earlier in these modules. I do like to enable the network or the transport name resolution and the MAC name resolution though. And in the protocols area under TCP, if I'm working on a busy network, I might tell Wireshark that I don't want it to reassemble TCP streams. I'll keep that off by default just in case I hit a busy network. I do like validating the TCP checksums, but then again, if I have checksum offloading, I'm going to get rid of that because it'll be irritating. I like to turn on the relative sequence numbers and window scaling option. I really like the relative sequence numbers piece. Now this piece that we didn't talk about is doing a heuristic subdissector, which means that even though a communication is running over another port, Wireshark is smart enough to look at the communications and say, wait a minute, this is not what I thought it was. This is actually HTTP, and I will dissect it as HTTP traffic, even though it's not running on port 80. In the area of IP communications, the IP global preferences, I will leave the reassemble fragmented IP datagrams off, but if I see a lot of packets that are maximum size, they might be fragmented. Maybe I want to check on that just to see if that's true. If I'm working on a really busy network, I might get rid of the validate IP checksums if possible. And those are the main areas where I go through and I edit the preferences. Remember that after you change those preferences, click apply. And if you've done anything having to do with the columns, you've added any sort of columns along here, whether it's a length column or you've changed the order of the columns, remember that you'll have to restart Wireshark for those changes to take effect. All the other changes should be dynamic in Wireshark.